this is it for the physics of the ocean, or let's say the ocean circulation, because we're still in the physics when we talk about the sea ice in the ocean. And so now Laurent Bertino was already introduced, but I will do it now from NERSC, and he will show you what sea ice reanalyses are about. Thank you.
Thank you, Marie. So, yes, 5th of June, it's me again, and straight to the facts. We are going to talk about the sea ice, and to show you a bit of the context. I don't know if these animations will work. Yes, they do. That's just 2 years of how the sea ice changes with seasons in the Arctic and the Antarctic. And you'll notice I've put a map of France here for scale. And it's not, it's giving you an impression of how the sheer importance of this in terms of albedo and the interactions between the oceans and the atmosphere that represents. If you have a critical eye, you'll notice as well a difference of features in the Arctic and Antarctic sea ice. That's not, well, there is a difference of sea ice physics, whether you're in the Arctic and Antarctic, but the difference you see here is mostly about the choice of the models and the rheology. But I'm going to come back to that. So, nope, that's the wrong direction, sorry. And the sea ice, as I mentioned, does control a lot of interactions in the ocean and in the atmosphere. There's also the processes within the ice, with the convergence, diversion of ice, and the breaking of ice by the waves, that all come into a very complex interplay of processes. And the sun will or will not go through the ice and start blooms under the ice and into the ocean. So, that being said, how do we know what happened to the sea ice? Well, we've had satellites, and then really the heads up to the NASA and NOAA teams for having sea ice satellite observations ever since the late 70s. And these data have given us, say, a top view of the ice. So what's the area coverage of the ice? And what you can see from that is the classical numbers. There has been a decline of the ice in the Arctic. There's been apparently an increase of sea ice in the Antarctic. There was steering a lot of discussions until 2016, when the ice suddenly dropped, and proving people right that yes, there is also a negative trend in the Antarctic. That's from the observations. And when you switch that to models, the models can give you also an uncertainty estimate from different models, here from the global reanalysis, and also in the Arctic. So we know the mean, we know the trend. What else do we want to know? That was one variable from sea ice. That was the concentration, the sole area view. There's more to sea ice than just the area view. There's the sea ice drift. So how fast are these movements? Are they accelerating? Are they getting slower? And the trends of sea ice thickness. And for sea ice thickness, I have to use 2 bars here, because there's been really different periods of observations of sea ice thickness. The first attempts with early altimeters, and I show here ENVISAT, which were not complete, which had a very large polar hole. And there's been also ISAT, I don't show it here, but that also gave sea ice thickness maybe more precise, more closer to the North Pole, but during 2, campaigns during the year, so not complete yearly coverage. Only since 2010 do we have SMOS and Cryosat-2 that give us sea ice thickness data, not year-round, but mostly in the winter. There's also a year-round product from Cryosat-2, but it's still not yet completely accepted by the community. It's a very, very nice start, however. There's a little box here in the corner, snow. Snow is, has been, measured in the early years of, in situ measurements in the Arctic as something, well, vaguely interesting, because ships could get stuck in the viscous snow on the ice. But now, it turns out that snow is incredibly important also as a loading on top of the ice to transfer the freeboard of the ice into real thickness. So that's made snow measurements much more interesting. Also because snow is an insulator for sea ice, and it does provide, more snow will delay the melting or the freezing of sea ice. Then there's two satellites I would like to show also on the sidebar here. That's future satellites, Simmer and Crystal, which will continue measuring passive microwave and altimeter data, and these are approved missions from ESA. So these will be very interesting. We hope there will be still some sea ice to observe in that moment. Next, we will be able to say more precisely what's the total volume budget of the ice. So that's the an estimate that we've provided at the NASA Center in a project that blends a reanalysis with machine learning. And if I can show you why, that's because sea ice thickness observations already started very late. So they came in 2010, it was after the action, because most of the sea ice loss has been actually in 2007, 2008. So what we can do is try to go back in time and extrapolate, not in forecast mode, but in hindcast mode, what were the sea ice thickness values post-processed, knowing what we know from the last 10 years or 15 years of sea ice measurements, thickness measurements. So, yes, it's the spiral of sea ice volume. It does progressively, approach the psychological limit of the zero sea ice volume in the middle, and a bit closer every year. So that will take a bit of time. We're in 2000s, still, well, 2000 was still the good years. It was still time we would focusing about on the area coverage of sea ice, and now comes 2004, and it starts to come a bit closer. Oh, and there's some dips in the summer, as you see. The months are the polar coordinates. September minimum getting more and more minimum. And yes, the winter ice decreases as well. You see more spacing between the lines. And then we come to the years 2007, 2008, and that's when the Arctic comes into a new regime, and that's been, observed from the Fram Strait moorings, where you can see all of the ice that comes out of the Arctic, and it's 10% of all the ice of the Arctic that's flushed through the Fram Strait every year, and that gives a very good sampling of what's the sea ice in the Arctic this year. And now, well, the ice is much thinner, pretty much everywhere. It's mostly first-year ice. There's hardly any old ice more than 3 and 4 years left again. And yes, it's getting dangerously close to this psychological limit in the middle of the circle. But ever since, well, we're more or less, we could say we're more in a new stable situation. The decline of volume is stabilized, and there are years when it's a bit less, but the trend is still much lower than used to be in the 2000s. Right. The trends now also can be estimated from different satellite processing. There's a lot of machine learning techniques being used for altimeter, but also passive microwave data, more surprisingly. And the trends, well, they agree qualitatively, but in numbers, they're still quite different from each other. So we still have a job to do to quantify the thickness of the ice more precisely. So there's different models having reanalysis. I'll show you 3 of them from SMWF, Mercator, and CMCC. That's the global reanalysis available from CMEMS. There's regional reanalysis also from different models. And you see that the values are very different. If you just point at one area in the Arctic, also the texture and the aspect of the ice is very different. And also because they're all done to the best of people's ability and using advanced tools, but still with large differences in how the systems are set up. In the Antarctic as well, you may see that there's maybe more resemblances, but I don't know if that's because the models are more like each other, there's more cross-pollination between the models, or if it's actually truly less uncertainty. So what can we do? Well, I've shown you one example of what we could do with machine learning. There's other things you could do, which is, for example, to take the observations that are in coarse resolution and enhance the resolution from what you know of true high-resolution data. And so that's, for example, ISAT2, or it could be high-resolution modeling. And then we can go also back in time, as I showed you this pre-2010 extrapolation of data. That's something that is doable with machine learning. It's just really an advanced statistical techniques. And then, once you're, say, very fluent with machine learning, you can also make forecasts of all the important variables, the drift, the thickness, the snow depth, if you can, and produce forecasts, but much faster and cheaper and more often. Yes, so that's the latest news. Thank you for your attention. Who's next?
Thank you, Laurent. That also shows the need to really evaluate the current CI's Reanalysis products and intercompare them to understand where they agree, where they disagree. And this is really what our project is about. So we didn't say that at the beginning. There was some turmoil with the beginning of our session, but this project is a decade, is a UN decade action, and so the purpose of this event is also to celebrate the thing that we are starting this initiative of intercomparison. It is international, and we would like to, as much as possible, all the groups that produce or use Reanalysis to join us in this intercomparison. It's still open. We are already organizing groups to intercompare CIs, to intercompare ocean currents, to intercompare ocean warming in these products, globally or regionally. And so contact us to join this exercise. And so we have